Okay, so we're going to do the second half of 1.5 here, 1.5b, which is still solving inequalities, but we're going to get into a couple special cases. Something a little bit different happens, and then into compound inequalities. We're still going to talk interval notation, and I'm going to want all your answers in interval notation. You need to be able to write interval notation for what we do in the future here. So we're going to take a look here at this first example, and again, solving it normally, we would distribute the negative 2. So the negative 2 would go to the 3x and give me negative 6x. The negative 2 would go to the 1 and would give me a minus 2. And that's greater than negative 6x plus 7. If you're observant, you see that the negative 6x's are the same. If not, we're going to get the x's on the same side, so we're going to add 6x to both sides. That would give me negative 2 is greater than 7. Now, unlike the equations where you just have two numbers that aren't equal to each other, you actually have to read this. What does this say? This says negative 2 is greater than 7. We've got to ask ourselves, is negative 2 greater than 7? And the answer to that is no. If we have a false statement, that means that there is no solution for this problem. Okay, so we solved it. My variables canceled. So we see my variables canceled here, and I'm left with negative 2 is greater than 7. Tells us that there is no solution to that problem. Okay, likewise, if I go through and do this next problem here, and it would give me a 10x, distribute the 5 here, would be minus 15. Minus 7x is less than or equal to 3x plus 8. And I would combine like terms on this side. So I got 10x minus 7x, which is a 3x, minus 15 is less than or equal to 3x plus 8. And when I add or subtract 3x from both sides, sorry, I'm running out of room here, that would leave me with a negative 15 is less than or equal to 8. Notice both variables canceled, so I'm just left with the numbers. Is negative 15 less than or equal to 8? The answer is yes, and this would be infinite solutions. Okay, so this right here would be infinite solutions. So if you have problems that ask you, like in these problems, is the inequality always, sometimes, or never true? This one right here would be never because there's no solution. This one would be always because there's infinite solutions. And if you actually get an answer like we did last class, then it's just sometimes. So let's take a look at the next type of problem here. So the next thing we're going to talk about is compound inequalities. Okay, compound inequalities, and we're going to deal with this also in 1.6, so it's important that you kind of learn what we're talking about here, how to answer these, how to solve these. You can join two inequalities with the word and or. So these are all going to be and or ors. The nice thing in this section, it literally says the word and or the word or. And all that the word and means is that it's included. So everything in between the two answers that we get is going to be my solution. So what is the solution of 7 is less than 2x plus 1? I'm going to solve for x. So using inverse operations would give me 6 is less than 2x. I'm going to divide by 2. It's going to give me 3 is less than x. I don't like the way that's read, so I'm going to put the x first. Notice if I flip the x and the number, that I have to flip the symbol as well. So I got x is greater than 3. I'm going to put the word and here because now I'm going to solve this other problem just like I would. I've got 3 times x is less than or equal to 18. So I divide by 3, and that gives me x is less than or equal to 6. So, and x is less than or equal to 6. So if I were to graph this on a number line, here would be my 3. Here would be my 6. The 3 would be an open dot because it's not included. It's just a greater than symbol. The 6 would be a closed dot, and I would shade everything in between here. It's everything in between. The word and means you're including everything between. So in interval notation, remember from yesterday that we have 3. Okay, would the 3 have a parentheses or a bracket around it? It would have a parentheses because it's just a greater than symbol. And then it would go to the number 6. And that has a bracket because it is included because of the less than or equal to. So again, it's all the numbers between 3 and 6. So I could say 3.2. Yes, that is in the solution. 5.8. Yes, that is part of the solution. So that's how you solve an and inequality. We'll go over to an or. Or means either one of these is correct. So again, it literally says the word or here. So again, it could be one or the other. So for this problem, I'm going to solve for k. So just subtract 7. That gives me k is greater than or equal to negative 1. Or I'm going to subtract 8 from both sides. K is less than negative 5. So I have k is less than negative 5. So again, if I were to graph this on a number line, putting them in order, that would be -5. That would be -1, right? -5 is less than 1, so it's on the left. This would be an open dot, and it would be everything to the left. At -1, it's a closed dot because it's a greater than or equal to. Greater than or equal to tells me to go to the right. So again, it's everything to the left, everything to the right. So an or compound inequality, and with ors, they always go like this with interval notation. It's always going to start at -infinity. It's going to go to the first number that we solved for, which was -5. And because it's an open dot or just a less than symbol, it's going to be a parentheses. Okay, we used a little U symbol, which just means union of, okay? Or you can also write the word or there. That's fine as well. So now I have a bracket because at -1, it's a closed dot, and that arrow goes all the way to +infinity. So it will look like this. So again, anytime that you have a or inequality, it will always start at -infinity. It will end at whatever your first answer is, the smaller number. Then you'll have a gap. Then it'll start back up at whatever your largest answer was, and it will end at +infinity. Every single compound or inequality will look like this, and every single and compound inequality will almost look like a ordered pair with two numbers. Okay. Again, why are we using parentheses and brackets? It goes back to interval notation from yesterday's notes. There will be a delta assignment following these notes.